Okay, so for parametric study, we need to study the impact of one parameter on the performance of the whole system. So what are all the parameters that can impact a building performance during lateral loads? You guys name some. Tube system. You guys know what parameters that can impact the lateral load and the lateral load of a tall building? We talked about many, specifically for a tube system.
Thickness of the shear wall.
The thickness of the shear wall,
Spacing of the column.
the what? The dimensions of the columns and the spacing of the columns,
Depth of beam.
the depth of the spandrel beam and the width of the spandrel beam and the coupling beam depth and width. So all these parameters can impact the lateral performance. So the bigger the dimensions, definitely the better the performance, because it's gonna be more stiff building, right? But what do you think the most parameters that can impact the performance? Like, we named some, but actually some of them are not important. Let's start with what is not important that much. Of these parameters, we talked about the spacing between columns, the columns dimension, the shear wall thickness, the spandrel beam depths and widths, the coupling beam depths and widths. Do you guys know the difference between the spandrel and the coupling? The spandrel is the one around the tube. The coupling is the one that couples the shear wall. Definitely the widths, it doesn't impact much. The widths either of the coupling beam or the spandrel beam. Yeah, it has some impact, but just a little impact. The one that impacts more is the depths of the beams. Okay, so like in the analysis of any beam that had gravity loads, the widths is important, but the most important thing is the depths. That's what gives them more stiffness, because this is the dimension that are cubed. Do you guys remember the inertia of the beam? It's AB cubed. B is the depth. It's to the power cube. The more you increase it, you are multiplied by cube. So, all right. So that's why I limited our parametric study on the most important parameters, which are the spandrel beam depth and the shear wall thickness I get. No, I believe every one of you have one specific shear wall, but I also changed the coupling beam depth. So we have the spandrel beam depth and the coupling beam depth. Let's see, I'm gonna come here. So like here, for example, this is one group, okay? All right, so this group, for example, the one that I haven't read, that's the base model. Like the base model is gonna be okay, so we're gonna have a base model, and in this base model, we are gonna change just the spandrel beam depths, and all the other parameters are gonna be constant. And for the base model, we are gonna change the coupling beam depths, and everything's gonna be constant. So this is the model that you should start with. Like this is the model that you should build in ETAPS. And then once you finish this model, you save as this model, and then start with the modification. So you select all the beams, all the coupling beams, and then change the depths from 50 or 75 centimeter to 1 meter. And then save as 1.2 meter, save as 1.5 meter. So you have 5, it's not difficult. You're not gonna build a model from scratch. The only model that you're gonna build from scratch is the base model. But once you build this model, you are gonna save it as a base model. And then you select the parameter that you want to change. Like, let's say, for example, the spandrel beam, select all the spandrel beam in the entire building, and then assign new section. That only takes 1 minute. You build the second one. Okay, so let's say that you built the base model. So let's see what you're going to change. We need to study the effects or the impact of the spandrel beam depth. So for the same base model, well, if you look, you'll find all the dimensions are the same like here. Except just this model is gonna start by 75, 100, 125, 150. But for the 150, you don't have to change it because it's already the base model. All right. So this is for the first parameter. Let's check the second parameter, the effect of the coupling beam depth. So you'll find here right now where we don't have 75 or 100, it's the base model depths. And then we only gonna change the depths, 75, 100, 125, 150, but you already have the 75 in the the 150 in the base model, right? So it's basically 3 models and 3 models, right? Not 4, because you already, one of them are already the base model. The next model is the effect of the shear wall depth. So everything is constant, and then you are gonna change the shear wall thickness from, it should be thickness, not depth. So from 150, you're gonna make it 75, 100, 125, and 150. So right now we have how many models? Okay, 3, 3, and 3, that's 9, and the base model is 10. So we have 10 models till now, okay? Let's see what is next. For the base model, you are gonna do something. What is it? You are gonna build outriggers. So you're gonna have a base model with outrigger and without outrigger. Okay? So, and for each group, I'm gonna give the outrigger, for example, in a story 15 and a story 45. Okay, so we're gonna have 2 outriggers in the same model. So right now, this is model number 11. So we have 11 models. So the 12 model, which is bonus, like you're gonna get 5% extra if you did tracing. Okay, so tracing is on the base model, you are gonna like throw an element in the 3D that makes like a brace around the building. Okay, I'm gonna show you how to do it, but it's very easy. You're just like facing one side and you start the element, like maybe you define a steel beam or a concrete beam, and you keep connecting the stories diagonally until you get the other side, and then it goes to the other side and keep drawing it. We didn't draw in 3D, but you can do it, maybe you can do it in 2D. And once you finish this side, flip to the other side and keep drawing it. Okay, but just make sure that all connects together. Like if you are drawing from this face and this face, they are all should connect together. So right now, how many models do we have? 12, okay, so I believe that's the 12 models. All right, you build the models. That's the step number 1. We build the models without anything, okay? And then we apply, but for the base model, once you build the geometry, you assign the earthquake weight. I'm gonna tell you how to assign the earthquake weight, so that you don't have to define the earthquake weight for each model. Once you save as, the model is gonna be saved with the loads on it. Okay, so you don't have to define the load again, all right? So that's a one note to be said right now. The other note, the columns. So the columns, if you can see here, like I put the columns like it keep it changing every 10 stories since we have 60 stories. So the columns dimension from 1 to 10 is 150, and from 11 to 20 is 130 until you go at 50. By 50, that's a square column, okay? So 50, I mean 50 by 50. Until you come to story from 51 to 60, okay? So columns is being changing. Well, from my perspective, what I would do, I make all the columns the same dimension, and then I select, I get the 3D view, and then select story 21 from this, for the story like from 21 up to 26. But if you want to do it step by step, it's the same. Like when you replicate, don't replicate the 60 story. You replicate, for example, until 11 stories. And in the 11th story, you select the columns in the 11th story, change them, and then replicate them for the next 10 story. And then you're gonna have the story in 21. Select this story, do the adjustment, and then replicate again. So you do it on 6 steps. All right? So
That's in meters, that's spacing.
yeah, that's also one of the things that I want to talk about. So this is the spacing between columns. It's a constant per group, because if I change this, you have to change the base model, because you have to redraw the building again, because that's something that needs to be changed in AutoCAD file. So like for this group, the spacing between columns center to center is 2.5 meters. Okay, so from the center to center, not the clear spacing. So that's an example of one group. So if like this group right now know exactly what he's gonna do. How about the other group, if you want to use this as an example? An example, let's say group 2. Group 2, the base model here is have a spandrel beam dimension of 50 by 125, and the spacing is 3. And this is the base model parameters. And you keep it changing the other parameters. So are we okay, or we need to clear it out? So I mean, like, this is the base model, this is the dimensions. And this is the dimensions. So as you can see, the other group has different base model, 50, 125, and the spacing is different. So you need to redraw, make sure that the AutoCAD file that you have has a spacing between columns 3 meters, center to center, right? And here this group is 3.5 meters. Okay. Does anybody have any question on this? It's clear, right? Okay.
So for the person, are we supposed to just make one configuration only, or we can have different configuration for the pressing?
What do you mean configuration?
Like, the dimensions of the pressing members or something like that.
I don't understand the question. You say for the base model here.
No, for the pressing.
Bracing. Yeah, so just like, I don't think that you have a lot of options, but maybe you can, So what I would do, like I have my building, I already have the base model. I just like try to connect each story with a member, like let's say.
The dimensions you want.
Yeah. Maybe, yeah, you can use maybe the column dimension, you can make a steel beam. We all need the stiffness, not whatever the cross section is. We are not doing design, it's just analysis. So let's say my building is like this. And I have, these are my stories in ETABS. So what I'm gonna do, I'm gonna connect the here to here, and then here to here. I go story by story. And once I hit here, I go the other way. And same thing from the other side. I keep doing the same until I get to the other story. All right. It doesn't mean that it's have to be like here. Like it's okay if it's hitting the like a specific story, something like this, that's fine. Okay.
The bracing go the base model only or the ones that we changing the parameters?
No, just the base model and see how is it with tracing and without tracing. Yeah. Well, I had some students from previous years, they even do beyond what I asked, like they study how, because they got like a huge grid. And they said, okay, I'm gonna do the tracing with the maximum everything. So not the base model, but I believe the base model is the maximum one, like if you look, but not for every group actually. Yeah, the first group has the maximum. So from what I see right now, which group should get the less drift? First one, right? Because it has the least spacing, the biggest dimensions of the spandrel beam, the biggest dimension of the coupling. So that's actually task, the second task. Like once you finish the modeling, you have to share the data between each other. So what I mean by sharing the data, like right now, once you finalize your analysis, you are gonna have, for example, a table. Okay, and this table is gonna have the parameters that we are gonna study on the rows. Like let's say, sorry, we're gonna have model 1, 2, 3, 4, up to 12 models. Okay. Then what we want to study, we want to study the total drift. Like I want to know when you push your building with an earthquake, how much is the total drift at the building? Like, is it 0.5 meter? Is it 1 meter, 2 meters? Like you want the maximum drift. Okay, that's the total or the maximum drift. And then I want to know the maximum inter-story drift. Like when this building is start to move, like it makes something like this, I want to know what is the maximum inter-story drift, the difference here between this and this. Like, let's say the difference between this story and this story is 1 centimeter. This is 2 centimeter. I want to know the maximum. ETABS can give this information. I'm going to show you how. And I want to know the shear lag. The shear lag is the one that is going to take a lot of time to get, because you have to cut here and then export the data from here to Excel and then draw it on Excel. So it's gonna take some time to get the shear lag, how it's look like. So that's gonna be a little bit difficult, but I'm gonna show you how. What else that we want to do? Yeah, maybe we are gonna look at other parameters, but that's what I'm saying. So you have all this for each model. So you are gonna draw a curve. Like we're gonna see how, for example, the coupling beam like here, we need to see how the spandrel beam depth is impacting the, like here, I'm gonna make a curve, and on the curve axis, I'm gonna put the depths of the beam, and here I'm gonna look at the total drift, delta, and for example, it's gonna be something like this. I wanna see that plot, okay? Same thing, the depths on the interstory drift, the depths on the shear lag, we're gonna have multiple curves. Okay, so that's the spandrel beam depths. So how about the coupling beam depths? How about the shear wall thickness? We're gonna see the impact of these. And one other thing, I wanna see the impact of the column spacing. Since all of you only used one column spacing, like you used 2.5, you used 3.5, so you need to provide your data to the other team so that he can plot the impact of the spacing. Okay, so that's one thing that I want to see. All right, so hopefully you guys have the models right, and can share the data between each other so that you can plot the 3 curves, or how many curves, I don't know, like 3 curves, and see how's the impact of the spacing between columns on the total drift, interstory drift, shear lag, whatever parameters that we are studying. Is that clear? Right? So once you have any questions while building the models and everything, we are gonna solve it together. But I believe right now you have all the needed information to start building your model, start using your time. We have, I don't know, like 5 weeks from now. So try to use your time wisely, okay? All right, so do you remember last time, where did we stop? So we stopped at, we were trying, importing from AutoCAD. So when I go to my office, I left my computer cool a little bit, and everything was loaded. Like it was something like this. After I got it to ETABS, it takes, I don't know, like 15 minutes or something. So you need to wait a little bit, but I know that my computer is very old. I have this computer like 2018 or something. So it's, I mean, and this is ETABS 222 or something. So that's really advanced one. So it takes a lot from the computer memory. So it depends on how powerful is your computer is. It's gonna be loaded fast. Okay, so right now I didn't do anything. I just imported an AutoCAD drawing to ETABS. All right. So one thing that I want to tell you guys, that when you build this model, try to use high performance concrete material. Like if you use the 4000 BSI, or the materials that are in ETABS, that's the one that is used in the regular buildings. And it's okay, we use it also in tall buildings, but we don't use it for the columns and shear walls. Columns and shear walls need to be in ultra high performance concrete, like mega strengths. Strength is very high. The compressive strengths sometimes reach 100 megapascal. So, but you will tell me how this is going to impact the analysis. So you have to do some calculation. So let's say in ETABS, the FCU is the 40 megapascal, or the 4000 PSI, or whatever. But let's say I have the 40, there is a rule that you can get the Young's modulus from the FC. I believe it was 4700 root FCU. I wrote it before, right? This is the compressive strength of the concrete. Like if you put it in a test and try to compress it, it's gonna fail at 40 megapascal. So for tall buildings, we need much higher strength, maybe double this number. So what you are gonna do, and this is gonna really impact the performance of the building, because once you increase E, you increase the stiffness of the building. Not this, like the stiffness is, the stiffness, like the inertia. So when you push the building, it depends on the stiffness of the building, and the stiffness of the building depends on the inertia and the Young's modulus, EI. That's the most important thing when it comes to bending moments. You guys remember, we always, when we get the deflection, it's function in E and I. So that's 2 important parameter, E as well. Like what we are doing here, we are increasing the inertia. In this parametric study, we are increasing P, the depths, the thickness. All this is increasing I, which is ABQ over 12. But this is also important as well. Can you imagine if this multiplied by 2, how it's gonna happen here? Because it's always EI and it's gonna be 2 EI. It's gonna be much bigger. So what I want you to do your research, try to research high performance or high strength concrete. And maybe I believe there's, right now, they got like up to 100 megapascal or something. And use like, let's say, I'm gonna use FCU 100 megapascal. And then try to see what is the new Young's modulus for this concrete. What is the new the epsilon for this concrete, like the ratio between the longitudinal strain over the strain, the Poisson ratio, yeah. So between the two strains, so I believe it's gonna be the same 0.2, but this is the most important one. E. Okay, so try to search these parameters because this is gonna affect. So I define new material and check the cross sections. Like what I'm gonna do right now. If you guys remember the first thing, once I put this, I go to okay, display architecture plans, and I go to columns and I add column objects. It takes some time actually to extrude all the column objects. So I can prepare this time and I got a one that I already have the column objects extruded. And let me leave this one. All right. So assuming that once we did extruded objects, we are gonna let it run. We will see how long it's gonna take until we extrude the whole object. But let's say it's already extruded. So the next thing is I will go to walls. Walls is here. And then I'm gonna say add wall object. So since we don't have too much walls, it's supposed not to take much time. Oh, it didn't put any walls. Okay, well, actually it's done here. So the columns are here. So I tried actually to open 4 ETAPS windows, so we don't wait until the software load. So here I have the columns are already loaded, and that's the first step. The second step, I want to draw the columns. I want to draw the the walls, then the beams, then the slab. So that's how the columns look like. But since the computer is slow, let's work with only one window. And let's make this 3D so that we can see the walls. All right. So I'm gonna come here and then add wall object. I don't know why it doesn't add walls object here. So check this layer. And this layer is columns and walls, so it should add walls object. Okay, so since it's not working, it was working yesterday. So what I'm gonna do, I'm gonna draw the walls by myself. Well, the most time-intensive job here was to drawing these 100 columns. So for walls, I can actually come here and then start drawing them one by one. And I believe the one that I have, okay. Let's say that this is the wall that I want to draw. So I will come here at this point and make sure that you are picking the right, you are snapping to the right location. And then here. Sounds like it's not the right dimension. So what I would do is I would go to define section and I change the section. Like for example, I can click on this and then I'm gonna hit assign shell wall section and go modify this section. In this section, I'm gonna make it 0.7 or 700 millimeter because that's the thickness that I have in this file. So right now it matches the dimensions that we have, but if I said add wall object, it should be added with the same dimension of the polyline that I drew.
What would cost that?
Hmm?
What would that cost if just more? Could be the.
I don't know, maybe because I deleted them, because I already developed this and just deleted just to explain it to you how to do it. Because I have like 4 models here so that we don't waste time waiting the model to run or performing any analysis. But yeah, it take like 1 or 2 minutes. So, and let's say if I want to draw the other one, right now wall 1 is 0.7. I can zoom in if I can't catch the point, and then I zoom out. And then here. Right. So let's see in the 3D. Yeah, all of them are here. So if you want to draw the spandrel beam, I taught you before how to do it. So you basically like drawing a normal wall just to change this from pier to spandrel. And then based on the spandrel on the coupling beam depth, you are gonna change the depths below. Let's say it was 1 meter, but I want to make sure that my units are consistent. So because I believe it's right now millimeter. So anything I put, it's gonna be millimeter. So I'm gonna change this to meter and this to ton force, and I'm gonna hit OK. All right, so then right now I can put this as a 1, and once I draw this here, if you see, I drew it a little bit back because it wasn't that accurate. I have lots of lines that what makes it not accurate. But if you brought this from AutoCAD, it should be fine. And I would recommend when you do this on AutoCAD, try to not to import the grids and try not to import the hatch, because when I'm trying to connect it, keep capturing other lines. But if I only have this lines, the boundary, it doesn't get, the snap doesn't snap to other lines. So I would delete the hatch for the columns and just the boundary layer of the columns and the boundary layer of the walls and the boundary layer of the slab. That's it. So in ETABS, it doesn't get confused. And the best way to draw these columns, since you guys have a different spacing, what I would do is first I would draw the axes. Maybe you don't need the axis, but the axis, I always love to have axis when I draw. And for example, I will take copy of this column. And for example, I have a column spacing of 3 meters. So I take this and I make an array. And in the array, it should ask you, do you want bath array or rectangle? I'm gonna say rectangular array. And I'm gonna say the spacing, let's say the spacing between columns, let's say it's 3 meters. It's gonna be center to center. And
3. All right. Well, it made it 3. Okay, so well, so this is the spacing. I can do it that way. Let's say, I don't know, my computer is very slow. I can make it that way. So right now I created all the columns. I only need one line. So I'm gonna bring this back to here. Sorry. Computer is very slow. And then you can rotate it. Like I can make this and I can copy. Let's see, there's copy. Well, let's say rotate. Specify the base point. Then should be in the middle. And then you can, if you have control while doing this, I believe it should copy or control something. So that's how I would do it, like so that you don't have to draw them one by one. So I made an array, then I can take copy this and then repeat it, and then repeat it the other way, and then I copy this and put it the other way, and then I would do these one by one. That's why I need grids so that I can put them. So this is how you create the spacing. And as I told you, while drawing this, try to make the internal columns align with the shear wall. So when you put an outrigger, the outrigger cross the shear wall with the columns on the same line. Do you guys understand that? Okay, try as much as you can. If it's not, that's fine. Not that big deal. Okay, so that's also one of the things that I want to talk about.
I will specify space. You just need to
Mhm.
make sure they're all aligned. Internal columns.
Yeah, like they align with the shear wall, and maybe they can align with the columns here or not. Maybe it's not like you don't have to align them with the column here. But for me, I would do it on the grid so that it can be symmetric. Okay. All right. Let's get back to ETABS. So if I want to see this in 3D, see if the shear wall is being drawn. Oh, the spandrel beam is not here. Interesting. Which one is that? Maybe it's small. Yeah, it sounds like it's drawy and it's still 1 millimeter. So that's why it didn't catch the units that we changed. Because we were doing, oh, it's still the same. Meter. Unforce, and then I will hit OK. So I'm not sure if I can modify this. Let's try to modify that. Anyway, so sounds like we draw them, but still 1 millimeter units. And okay, let's go back to plan. Story one, and I deleted a wall. All right. Right. So for the sake of time, because it's really slow here. So let's say that I already draw the spandrel beam here and here with the same dimensions that's in your base model. Okay, so you're gonna make the base model dimension, and you're gonna draw this,
You make sure that the units here are meter and ton, whatever the units that you are comfortable with. And then for the slab, what I would do, I can draw it here. If I want to, like it's just one rectangular area, that's it. But what I faced when I was drawing them, because I had mini grids line and everything, it took me some time to catch the point speed. So what I had to do, rather than doing rectangle, I had to do it with this, and I keep zooming in, click the point, zoom in, click the other point, zoom in one by one. So maybe it's much easier to draw it from AutoCAD than AutoCAD say assign slab or add slab object, okay? Same thing with the beam, like you have to zoom in because it's a really big model to do it. And it's not like the same, like other models, that's huge, 63 meter by 63 meter, have each side have like 33 column or something. So we have over 100 or 200 columns. So it's a huge model, takes a lot of time to zoom in and zoom out. So maybe it's much easier to do everything in AutoCAD and then bring it in. So once I have one story, that's done, you assign the loads. So the loads that we're gonna use the same that we have done for the other model. You have to write this because I don't have it written. So we're gonna have the own weights, so gravity loads. So we are gonna have one, the own weight. And we are gonna keep it as is. Number two, we have the flooring. And we are gonna say that the flooring is 0.15 ton per meter square. And number three, we're gonna have live load. And this is gonna be 0.2 ton per meter square. And then I assign it to this slab. Why? Because you need to do this before you do the replication. So when you replicate a story, it get replicated with the loads. But if you miss that, it's okay. Once you replicate the 60 stories, you can come to story number one and pick the slab. And then make sure that you have this changes from one story to all the stories. So anything that you are gonna assign here is gonna be assigned to the all stories. And yeah, so that's it for now. So also that can help you when you assign different beam dimensions or different columns dimension. You can swap between one story, similar stories, or all stories. You guys, we talked about this before, right? Okay, so let's say story number one is done and we need to start the replication. So what I'm gonna do, I'm gonna, first I need to check the grids, add and modify grids. Okay, I have 4 stories here. Let's modify or show stories. So I have the story number 4 is a master story. No, it's not a master story. It's a regular story. Story number 1 is the one that should be master story and all the others. So I had to change this. So let's quick add a story. So it adds story number 5. When we add story number 5, it's not master. Because if you keep this as a master story number 4, that's what I did yesterday. All the stories that I added became master, and I already added 60 stories. So I have to change them one by one. It's gonna take some time to change them. That's why I changed this to no master story. So what I'm gonna do, I'm gonna quick add stories until story number 60. So right now I didn't add the story, I just added prepare the grids. I added one more story. Okay, let's go to story number, this one. Right click and delete. This one, okay. So right now we have 60 stories. And these 60 story, what is gonna help you? Start right now, define who's master and who's not master. So I have from 1 to 10 master, and then 11 is gonna be a new master story. And then I will go to story number 21, and this is gonna be a master story. And then story number 30, 1, 41, and 51. And you have to change what is next. So you have this as a master story.
And then I'm gonna change these other stories to be similar to story number 1. And this one is gonna be similar to story number 1. If you don't want to do this, it's okay. Like if you can handle the structure, all of them without dealing with master and not master, just like a matter of organization. Just in case if you did something wrong to one of these stories and you don't want to change to the entire structure, you can do that. And then I come here, story number 12 is going to be similar to story number 11, and 13 is going to be to. So that's one thing that you can do. If you don't want to do it, that's fine. All right, let's say that you did this for the entire structure. I'm going to hit OK. And I'm going to look at this as structure. So what I'm going to do, I'm going to select everything here. So I have to go to view, set 3D view. And I'm going to look at XZ view. View, set 3D view. I'm going to make the aperture angle 0. All right. So right now I have a story number 1. And let's say that you have the columns that I mentioned that you have in your model. So make sure about that, like go to your base model and check the columns, like the group that has the columns 150, need to stick with 150. The group that has the columns, where's the column? Yeah, there's 150. Actually, all of you are the same. So you have 150 up to 50. So the one below, the one that I have right now is 1 meter. So make sure that the ones that you have is 150. So don't use the model that I gave to you. You have to change the cross section, check everything. Okay. Like if I went to AutoCAD and measure dimensions of the columns that I have here. That is 1 meter. So yours is bigger, is 150 centimeter. Okay, so let's get back here. So I selected all this, and what I'm gonna do, I'm gonna go to edit, replicate, and I'm gonna replicate this story in the next nine stories. Like I will go to replicate, and then I hit story, and replicate this story in story number 2 up to story number 10. And I'm gonna hit apply, and I'm done with this. Well, to be honest, I need it also for 11. Takes time. Okay, it's done. So I'm gonna do another one at story number 11. I'm gonna hit apply. Oh yeah, I can do this because I have to reselect this story again. Okay, well, I can select this story. It's much easier. And then I'm gonna replicate this story in story number 11. And then I'm gonna hit okay. Do you guys know why did I do that? Because that's the one that I'm gonna change the columns. Because if I change it 10, it's not gonna be similar to the other stories. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I have 11. So in 11, you can select all the columns here and define new column section and assign the new column section. So what I would do before I start the model, I define all the column sections that I have. I define the 5 section, the 150, the 130, the 100, the 175, the 50, all of them. I make them ready and assign them right away. Okay, so you go to assign frame section, and then you go to the new section and then assign it. But what I selected here is beams and columns. So I want to make sure that I only selected columns. So I can not select the columns, and I just select sorry, not selecting the beam. I only select the columns, and I have the shear wall selected, but this is not a problem The problem is if I have other frame section selected, so anything that I'm assigning is gonna assign a new frame section to the beam and to the column. Okay, so when I go here and I say assign frame section property, and I have here column 1 meter by 1 meter. So what I'm gonna do, I'm gonna go to modify, and I'm gonna add a copy of this property. And I'm gonna change this to column. Did I hit modify or I did add a copy? Add a copy, right? Yeah, 0.8 by 0.8. And I'm gonna change the dimension here to 0.8. And here's the 0.8. This is just an example. Okay. All right. So I have a new column, and then I'm gonna assign this new column. All right. I can click on undeformed shape. So this right now it shows me the different sections. And if you want to see the extruded view, it's gonna be something. Can you guys see the difference?
Yeah. A little bit. And then I replicate it to the other stories and I do the same thing. Okay, so once we are done, we're gonna have something. Once we are done with the 60 stories, it's gonna be something like this. Right? So that's the 60-story building. Columns are adjusted, and this is the only thing that you are adjusting, the columns. Okay, and that's actually some real buildings look like this. Maybe you'll say, oh, that's a lot of columns. No, there's a lot of buildings look exactly like this. It takes a unique shape from the distribution of the column, and we use like a unique facade that shows the window. That's all what you want from a building. And it's also economic because it doesn't have irregularity. When you have irregularity in the buildings, it's more cost. You have to come up with new systems. But this one, cost effective, complete direct tube system, takes all the load. You don't have to have shear walls everywhere. So, and inside the building, you can use the space because if you look at Burj Khalifa, walls are everywhere inside the building. Shear walls is almost cutting every space. But this one, look at the spacing that we have inside. So you have a lot of space. So not only economic from how much cost, but the space inside, it's usable. Okay. Anyway, so that's the building that we have. This building have gravity loads. I told you to assign this on the slab. So this building right now is ready to take the seismic load. Right? So are we all clear on that? Is that difficult? To
produce that.
how what?
How long do you produce the model?
It doesn't take that much time. Like if you have the AutoCAD file, if you have a good computer, you're gonna import in like 2 minutes and then assign the columns. Maybe it takes 10 minutes, 15 minutes. Assign everything. So to build the first one, maybe 1 hour, replicate it. And once you have the base model, save it, like don't touch it, don't change anything. And then keep adjusting the others, save as. And then once you have 12 models ready, but before you produce the 12 models, wait until you put the seismic load. Because you don't have to put the seismic load in each model separately. So you're gonna waste, I don't know, an hour to do them separately. So once you do this, put the seismic load and then produce the other models. Then the other models, everyone can be run separately. Like you guys team 4, everyone is gonna run 3 models. And run the 3 models and get the results. Maybe one team is gonna see the impact of the coupling beam depths, shear wall thickness, spandrel beam depths, and then you guys come together and put the results together. I believe that's an efficient way to do it. So is that okay? Good. All right. So that's for the producing the model. Okay. So we are done right now with the ETAPS part. Let me close Zoom.